Hello everyone, welcome back to another video. This is Pranav, and in this video we'll be talking about the MinMax algorithm. MinMax algorithm is a recursive or backtracking algorithm which is used in decision making and game theory. So it provides us an optimal move for the player, assuming that the opponent is also playing optimally. And basically, this algorithm uses the recursion to search through the game tree. Also, MinMax algorithm is mostly used in game playing, that is in applications in AI such as chess, checkers, tic-tac-toe, Go, and various two-player games wherein we have one player as a human and the other one would be the AI. So this algorithm computes the minimax decision for the current state. Coming to understanding the min-max, in this algorithm two players play the game. One is called the max and other is called min. So both the players fight it uh, as the opponent player and gets the minimum benefit while they get the maximum benefit. So uh, both players of the game are opponent of each other, wherein the max will select the maximized value and min will select the minimized value. So the minimax algorithm performs a DFS, that is depth first search algorithm, for the exploration of the complete game tree, and the algorithm proceeds all the way down to the terminal node of the tree and then backtracks it using recursion. So coming to the working part of the algorithm, the working of min-max can be easily described using an example like we have taken it in the next slide. I'll be showing it to you. So here we have a game tree which represents two-player game. In this example, let me just show it to you. So this is the example where we have two players, that is min and max. And in this example, one is called the maximizer and the other one is called the minimizer. So the maximizer basically will try to get the maximum possible score, and minimizer will try to get the minimum possible score. So this algorithm applies DFS as we just discussed, so that is depth first search, and in this game tree we have to go all the way through the leaves to reach the terminal nodes. And at the terminal node, the terminal values are also will are given, so we will compare those values and we'll use backtracking and the tree until the initial state occurs. So these are the following steps, wherein you can see in step 1, so we have the terminal nodes that are HIJK, LMNO, where we have the values that are -1 to 7, and we have maximizer node that is DEFG. So as we just discussed in step 1, basically the maximizer will try to get the maximum value. So out of this, from the D node, the maximum value is taken from I, that is 4, and as you can see in step 2, so step 1 is the initial game tree and step 2 is the next step, and you can see that the maximum values are taken from the terminal nodes into the maximizer node. So in the first step, the algorithm generates the entire game tree and then applies the utility function to get the utility values for the terminal states. So as we just saw in the game tree, so A is the initial state of the tree. Suppose maximizer takes first turn, which has worst case initial value, that is -infinity, and the minimizer will be initialized to the worst case initial value, that is +infinity. So we find utility values for the maximizer, that is -infinity, and so that we can compare each value in terminal state with the initial value of the maximizer, and it determines the higher node values. So it will find the maximum among all the nodes. So for D node, the maximum will be 4, that is from -1 to -infinity. The max is going to be 4, like here. You can see in D, it will check between -1 to +infinity, so -infinity. So the maximum is going to be 4. Similarly, we find the maximum for all the particular nodes. That is for node E, it is going to be 6. For node F, it is going to be -3. For node G, it is going to be 7. Then coming to the step 3 and step 4. So in step 3, you can see the next, using backtracking, the next very step is going to the upper node, that is B and C. So B and C is the minimizer node, where it will perform the function for minimizing the particular value. So out of D, E, F, G, the values assigned are 4, 6, -3 and 7 respectively. So in this we are going to check for the minimum value and assign it to the minimizer nodes. So in this step, it is done for minimizer, so it will compare all the node values within plus infinity, and we'll find the third layer node values. So for node B it is going to be 4, and for node C it is going to be -3. So once again it's a term for maximizer coming to the main root node. So it will again choose the maximum of all nodes for the values present in the child node. That is going to be 4. As you can see, 4 is greater than -3, so it is going to maximize the function. And using this particular method, that is recursion, we are going to find the most optimal value. So that was the complete workflow of the MinMax of two-player game. So coming to the properties of MinMax algorithm, the complete MinMax algorithm is pretty complete, and it will definitely find a solution if it exists, and in the finite search tree, that is in the range between finite sequences. So and it is very optimal. So MinMax algorithm is optimal if both operands are playing optimally, as it will calculate the moves equally, that is for minimum and maximum. Coming to time complexity, as it performs DFS, so for the game tree, so the time complexity of MinMax algorithm is capital O of B bar M, where where B is branching factor of the game tree and M is the maximum depth of the tree. So big O of B bar M is the time complexity. Coming to space complexity, it is going to be same, where it is going to be similar to the DFS one, that is big O of BM. So limitation of MinMax algorithm. The main drawback of this algorithm is that it gets really slow for complex games such as chess, Go, etc., as the number of moves are pretty high. So this type of game has huge branching factor, and it might create time complexity or space complexity as well, issues as well. So the player has a lot of choices to decide, and this limitation of MinMax algorithm can be improved from a topic called alpha beta pruning, wherein we are going to remove the particular branches that are not in use or not required, so that it makes it easier for the recursion method to find a particular solution path. uh, Coming to the conclusion of this particular topic, so it finds the MinMax algorithm finds applications in decision making processes across diverse fields. That is, its principles are leveraged in scenarios requiring optimal choices in the face of completing interests, contributing to fields like artificial intelligence, finance, and logistics. So this basically helps in decision making and finding the best particular path, and in a very simple way, and finding a definite solution, as we just saw. And as technology advances with the advent of machine learning and more sophisticated algorithms, the MinMax algorithm remains a foundational concept in broader landscape of decision making strategies. So its legacy endures as a testament to the fundamental principles of strategic thinking and optimization in the face of uncertainty. So thank you guys for watching the video. Hope you guys understood the topic.